Hey guys, I'm Georgia and welcome back for another episode in my history series where today we're going to be talking about the history of vaccines. Apparently because I just love putting myself in the firing line on the internet. No, I'm joking. I know vaccines are a touchy subject at the moment, but when I uploaded my video on smallpox and the Edward Jenner discovery of the first ever vaccine, I was expecting a fair amount of backlash, but actually almost everyone was very respectful and kind, and it made me realise what a good little corner of the internet we have here. So as promised in the smallpox video, here is the continuation of sorts, where we're going to take a look at the history of vaccines as a whole, from ancient Egypt to smallpox to today's COVID-19 vaccine. How did we get here? But before we get into the video, I just want to thank Native for sponsoring us this week. Native have recently launched their brand new hair care range with so many different scents to choose from, and when they contacted me about a sponsorship I was like, right, let me try these products and get back to you, because my hair is notoriously fussy. Like, I have used the same shampoo and conditioner for years because my hair just doesn't like anything else, and obviously as I'm here currently doing this sponsorship and telling you about it, I loved this shampoo and conditioner. Might help if I showed you the right way around. This shampoo and conditioner. I chose the Cucumber and Mint Volumizing Shampoo and Conditioner because I have the flattest, straightest hair ever. My hair just has no life to it. And this is designed to provide weightless lift for full and voluminous hair. It's my mission in life just to give my hair a little bit more volume, just to give it more life. And as you can see, this shampoo and conditioner, it definitely does. I washed my hair last night, I've used no extra products, and this is the result. Like, I have a little bit of volume in it, which never happens. Native also sent me the Almond and Shea Strengthening Mask, which nourishes strands and helps to replenish damaged hair by restoring moisture and reducing breakage, and she just smells divine. It smells so good. I have really been enjoying using these products. My hair feels and smells so nice all the time. I hate doing my hair, so a really simple, easy hair care routine is really important to me. If I feel like I get out of the shower and need to use a million more products just to make my hair look acceptable, that is just a huge no for me, and I don't have to do that with Native. There are only 10 ingredients. It's sulfate, dye, silicone and paraben free, as well as being cruelty free, and it's very easy to apply, lather and rinse. I really recommend giving Native hair care a go. You can try Native's new hair care range today using my link and code georgiam to get 20% off. That's shampoo and conditioner for only $14.40. And with my code you can also get 20% off of any deodorant or body wash as well. And with that, let's get back to some vaccines. So whilst Edward Jenner is widely considered the founder of vaccinology in the West after 1796 when he inoculated a young boy with cowpox, of course the history does go back much further than that, starting with this idea of inoculation. Inoculation is often used as a synonym for vaccination, but they actually do differ slightly. Inoculation is the act of implanting a disease inside a person or animal, whilst vaccination is the act of giving someone a vaccine specifically, a product designed to stimulate antibodies against a specific disease. As I always say in these videos, I am not a medical professional in any way. I'm just a nerd who loves researching medical history. If you are more knowledgeable than me and I get something wrong, then please do correct me in the comments. And do not take any of the medical stuff I say as gospel. I'm just a normal big old nerd. I'm not a doctor or a scientist or even a historian. I just like researching things. Also, if you are anti-vax, this video is quite clearly not the place for it. Any comments that aren't productive to genuine discussion around this topic will be deleted because, quite simply, my videos aren't a place for blatant, intentional misinformation. There's some evidence that the idea of inoculation originated in India or China sometime around 200 BCE. Because humankind has never really been stupid, it became clear to people very early on that once somebody had recovered from a disease, they never really got it again, or if they did, they get it to a much lesser extent. The idea that being infected with a small amount of a virus could potentially lead to a lesser infection has never really been groundbreaking. That idea comes from even earlier than 200 BCE from a guy called Thucydides, an ancient Greek man who wrote about a plague in Athens, and he noted that the very few people who recovered from this plague could tend to the sick without ever becoming infected again. So this idea has always been around. Although we don't know for sure what disease Thucydides was talking about, the likelihood is that it was smallpox, which has ravaged humankind for as long as history has been recorded. I'm not going to go into loads and loads of details about smallpox as a disease again. If you want a really deep dive, I recommend going back to watch my Edward Jenner and the smallpox vaccine video, but here's a brief overview for those of you who aren't going to do that. Smallpox is a serious infectious disease that's caused by the variola virus. It causes flu-like symptoms in the early days of sickness, so fever, severe fatigue, back pain, headaches. A few days later, you'll get these flat red spots appearing on your face, hands and forearms before they appear on your trunk. Within a couple of days, these will turn into small pus-filled blisters before they scab and fall off, leaving these deep pitted scars. Most people would recover, left with permanent scars over their body and face, or blindness in more serious cases, but 3 in 10 would die. And considering just how contagious smallpox was, that's a lot of people. What we're going to do today is delve much deeper into the history of smallpox. My last video spoke about smallpox as a disease and Edward Jenner and the vaccine, but we're talking history today. We're talking about the history of vaccines as a whole, and smallpox is one of the biggest and most important parts of that history, so it's got to be done. Whilst the origin of smallpox is still unknown, they found smallpox-like rashes on Egyptian mummies, which suggests it's been around for at least 3,000 years. If in doubt, there will always be an Egyptian mummy with evidence of any disease. The earliest written description of disease like smallpox appears in China in the 4th century. And I say like smallpox because it wasn't always called smallpox around the world at that point, so we don't know for sure that it's the same disease, but the symptoms were the same, so it's assumed that it likely was. As early as the year 910, there's a written account in Arabic by a Persian physician called Al-Razi or Al-Raziz, and the title is loosely translated to the Book on Smallpox and Measles, in which he wrote about the symptoms of each disease, and very importantly, he distinguished between them, noting the differences in symptoms and diagnosis. History has seen many plagues over the years, but seeing as smallpox and measles are fairly similar, it's not always clear which was the affliction. But we know from this point in history, from the 9th century, people had definitely distinguished between the two diseases. It was 100 or so years after that, so around the year 1000, that we see evidence of early inoculation in China. Inoculation, as I said at the beginning of this video, is the practice of artificially inducing immunity against a disease. Thousands of years ago, this meant something as simple as scratching matter from a smallpox sore into a healthy person's arm. Later accounts show that healthy people would inhale a powder made from the crust of smallpox scabs. Yes, as disgusting as it sounds. The book The Life and Death of Smallpox by Ian and Jennifer Glynn notes in the late 1600s, Emperor Kangxi had survived smallpox as a child, and when he had his own children, he was determined for them not to catch it. It was horrible, he didn't want his kids to go through that. So he had his kids inoculated by grinding up smallpox scabs and blowing it into their nostrils. For boys it had to be the right nostril and girls the left because, you know, history. But even before this point, inoculation had been going on for hundreds of years. There's even some evidence to suggest that sometimes a needle would be injected into a smallpox sore and then the pus was inserted underneath the skin of another healthy person before a paste made of boiled rice was placed over top of the hole. Minus the rice, this is more like the idea of vaccination that we have today. Over the next few centuries, smallpox continued to ravage the world as travel became more commonplace. In the 1520s, smallpox killed millions in Mexico, having been introduced to the country by Spanish conquerors. This is what weakened the Inca Empire to the point that it eventually died. Later that century, smallpox hit Chile, along with measles and typhus. This was a plague that killed a huge amount of the indigenous population. Remember that parts of the world, Asia specifically, have been dealing with smallpox for centuries already, so people had a natural level of immunity from the disease. From Asia, it quite easily travelled to Europe and Africa, but North and South America probably could have remained untouched for a while longer had colonisation not been such a high priority. These people in North and South America had no natural immunity. It was much more dangerous for the indigenous people of the Americas. In the early 1600s, 90% of indigenous people in Massachusetts Bay were killed by smallpox. In 1634, it was written by John Winthrop, a governor of the colony of Massachusetts, "The natives, they are all near dead of the smallpox, so as the Lord hath cleared out title to what we possess." Colonisers saw the smallpox epidemic as a gift from God, a sign they were doing the right thing. And it continued this way for centuries, ravaging the world. Meanwhile, over in China, this is when Emperor Kang supports inoculation, writing a letter to his descendants urging them to consider it to save their own lives. Word about inoculation eventually spread to Europe, where they used similar techniques, but they referred to it as variolation, in reference to the variola virus that caused the illness. Of course, although at that point they didn't know it was a virus, but yeah. The story of variolation in Europe begins around 1713, when a woman called Lady Mary Wortley Montagu's brother dies from smallpox, before she then contracts the disease a couple of years later, leaving her terribly scarred. I could make a whole video just about Lady Mary, who was somewhat of a rebellious woman in a very unrebellious time, but for the sake of this video, here's a quick synopsis. Lady Mary was born to a hugely wealthy family in England in 1689, and she basically rejected all of society's ideas of what a woman should be and do. She educated herself, she taught herself Latin, she loved to read, and she vowed very early on that she was going to be a writer one day. She refused to let her father choose her husband and instead eloped with a politician and became somewhat of a socialite, writing and publishing poems about her experience in high society. And not always nice poems either. And then smallpox hit, changing her family, changing everything forever. A year after Mary recovered from smallpox, her face now pitted and deeply scarred, her and her politician husband travelled to Constantinople, which is today's Istanbul in Turkey, and Lady Mary went along with him. But once there, she noted that barely anyone had the hallmark scarring of smallpox, something that was around every corner back home in the UK. She wrote in a letter back home, "I'm going to tell you a thing that will make you wish yourself here. The smallpox, so fatal and so general amongst us, is here entirely harmless." She goes on to explain in her letter how she's discovered that if somebody is found to have smallpox in Constantinople, the old women gather a group of people together and come in with the matter of the smallpox, which the old woman then injects directly into your vein with a large needle, giving you no more pain than a common scratch. That was inoculation seen firsthand. Mary, in what some say could be a moment of madness, but having seen the ravages of smallpox firsthand, made a decision to visit one of these women and have her 3-year-old son inoculated. He would be the first Englishman to be inoculated, as far as history knows anyway. And guess what? He never caught smallpox. At the end of her trip, Lady Mary became determined to bring inoculation back to England, but she's faced with a lot of opposition from pretty much everyone. I mean, not only was she a woman, she also learned this from the East. Yeah, racism and sexism combined just ensured that Lady Mary was screaming into the darkness with this. But luckily, she was never one to care what society thought of her. A few years later, she had another child, a daughter, and another smallpox epidemic struck London. So she invited an audience, including the King's own doctor, to come and watch her daughter be inoculated. Her daughter got a little bit sick, but recovered easily, and of course, never got smallpox. From here, more people started to show an interest in inoculation. Even the Princess of Wales asked her father-in-law, King George I, for permission to inoculate her children, a request that he refused until more testing had been done. This testing was conducted on prisoners and orphans until it was decided that eventually it was safe. After 2 of the King's granddaughters were inoculated, word spread like wildfire and it soon became fairly common practice across England. And I know what you're probably thinking, right? Like, how did they ensure that they weren't just giving full-blown smallpox to people via these procedures, like literally injecting the pus into their skin or scratching the scabs into them? Well, they didn't know they weren't giving them smallpox. It was a very risky procedure, but it did work more than it didn't, so they kind of just took these odds. This was the 1720s, 1730s, and it would be just decades later that Edward Jenner created the first ever vaccine. It's Edward Jenner's name that we know quite well today, but Lady Mary Montagu should be more widely applauded for her efforts, I say. She likely saved thousands of lives because she refused to be quiet about what she'd learned. Which brings us to Edward Jenner, who was a talented physician who for many years had heard rumours surrounding smallpox and cowpox. The milkmaids who'd caught cowpox from open sores on their cows' udders found themselves immune to smallpox, they just never caught it. And Jenner wasn't the first person to notice this connection. It was a rumour that had been flying around for many, many years. But he is thought to be the first one who took this thought and put it into real action, or at least was the first to publish his work and get it noticed. There's stories of how in 1791 a man called Peter Plett inoculated his 3 children with cowpox in what we'd now know as Germany, and another British man called Benjamin Jesty was said to have done the same to his 2 sons and wife in 1774, nearly 2 decades before this. The main difference between Jenner and Jesty is that Jenner was an actual physician, whilst Jesty was simply a farmer who dealt mostly in cattle. Naturally, being a farmer, Jesty made the connection between smallpox and cowpox like so many others had. In 1774, he took his wife and 2 sons to a neighbouring farmer's field where he knew cowpox was rife. Using his wife's knitting needle and material for one of the infected cows, literally just like pus from an open sore, he inoculated both his boys on one arm above the elbow and his wife below the elbow. His wife's arm got quite inflamed and she did get quite ill, causing them to call out the local surgeon, and from there word spread about what Jesty had done. But they all survived, and when the next smallpox epidemic came around, the surgeon inoculated the 2 Jesty boys and the other neighbourhood kids with actual smallpox material. All of the children acquired smallpox apart from the Jesty boys. Benjamin Jesty would be recognised by society for what he'd done to an extent, but it would be Edward Jenner who would receive the huge majority of the acclaim. As I said, he was an actual physician trained in the field, and Jenner had the means to take his discovery further. It wasn't a fluke. Again, I did make a whole video focusing specifically on Edward Jenner and his discovery of the smallpox vaccine, so if you want a really deep dive, then I would recommend you go over and watch that. But again, I'll give you the overview here. In 1796, a young milkmaid called Sarah Nelms came to Jenner with a cowpox pustule on her hand. Cowpox was actually quite rare in humans, you didn't see it very often, and Jenner had been pondering his theory about cowpox and smallpox for quite a while, so when Sarah Nelms came to him, he jumped at the opportunity. He took some of the matter from the cowpox pustule on Sarah's hand and injected it into the arm of an 8-year-old boy called James Phipps, who was the son of Jenner's gardener. James developed a scab and experienced some soreness and a mild fever, but he recovered over the next few days, no problem. 6 weeks later, Jenner inoculated James with actual smallpox matter, and would you know it, he would show no signs of the disease. Jenner would later publish his findings in a short treatise, and he called his procedure vaccination, after the Latin word vacca meaning cow. When the technique was stretched to other diseases, they kept the name vaccination in honour of Jenner. He did meet a fair amount of opposition from people who didn't want to inject cowpox into themselves, but soon vaccination replaced variolation or inoculation as it was deemed much safer, much less risky. And by 1853, so 30 years after Jenner died, smallpox vaccination became standard practice in the UK. It was actually made mandatory in the first 3 months of an infant's life, and the penalty for a parent not doing it was a fine or even imprisonment. Initially, the method of vaccination here was arm to arm, so the virus was taken from the pustule of a previous patient and transferred to a new one, and then the virus would be taken from that person, put into the next one, and so on. It was essentially a virus transfusion. Of course, this had its risks because they didn't have much understanding of blood-borne diseases at this time. It wasn't unheard of for patients to contract syphilis through this version of vaccination, which was pretty rife at the time. It was also eventually found that cowpox transmitted from human to human also decreased in potency over time. So by the late 1800s, this arm-to-arm method faded away to a different technique of growing the virus on calves and harvesting it directly from them, which highly reduced the risk of human bloodborne diseases. Of course, this did come then with the general risk of just cow diseases, so antibacterials were added to the vaccine, starting with glycerin and later antibiotics. It's crazy to think about now, but sometimes the infected cow would literally be walked around town for vaccinations, like it was that direct, being taken out of the cow, put into the human. Because of course the issue of storing and transporting vaccines was a huge one in a time before mass-produced needles and vials and transportable freezers. Heat is a vaccine's worst enemy, so things had to be refrigerated or frozen or dried to ensure a prolonged life, but technology wasn't quite there yet. The vaccines at this time could be stored for a very short time in small vials or on dried threads, but it would lose its effectiveness very quickly, often quicker than it could be transported for use. So they kind of stuck with the parading a live cow around town technique for many decades. In 1800, vaccination was taken over to the USA by a man called Benjamin Waterhouse, who was a Harvard professor, and he performed the first US vaccinations on his own children. Waterhouse put a lot of effort into encouraging public vaccination. He wrote to the then US President John Adams and then Vice President Thomas Jefferson when Adams showed little interest. In 1802, Massachusetts became the first US state to encourage the use of vaccination against smallpox, with Waterhouse convincing the city's Board of Health to sponsor a public test of vaccination, leading to 19 people being successfully vaccinated. But then, in a very American healthcare move of his, Waterhouse initially sought to retain a monopoly on the smallpox vaccine in North America, refusing to provide vaccine material to other doctors unless they paid him or gave him a portion of their profits. This led to physicians who couldn't afford it being forced to look elsewhere for vaccine material, looking to pustules on human patients. As we've already covered, the initial method of vaccination was arm-to-arm, pustule from a newly vaccinated patient used to vaccinate the next. One physician, desperate to vaccinate his patients but probably not completely understanding the process, used the material from a pustule of an actual smallpox sufferer, and 68 people ended up dying in Marblehead, Massachusetts. Eventually, other doctors started receiving genuine vaccine material from England, and Waterhouse was eventually forced to share his supplies. And then the US Congress established a national vaccine agency, which said that the US Post Office had to carry mail weighing up to 0.5 ounces for free if it contained smallpox vaccine material, just to enable this to get far and wide. In 1803, a mission was set out on to bring the vaccine to South America. King Charles IV of Spain commissioned the royal physician to get the vaccine to the Spanish colonies down there. So the physician sets off on a ship with 22 orphan children and a number of assistants. They planned to vaccinate the boys in sets of 2 throughout the trip, so they would have fresh cowpox pustules by the time they arrived. I mean, you have to admit, this is pretty smart for the early 1800s. So when they set off, they had 1 or maybe 2 boys with the cowpox pustule, and then throughout the trip they just transferred it from boy to boy to boy, so it was always fresh. When they eventually arrived in Caracas, I hope I'm pronouncing that right, only 1 of the children had a visible cowpox pustule, but this was enough to begin vaccination across all of South America. And according to historyofvaccines.org, you'll be pleased to know that all 22 children were educated and adopted in Mexico at the Spanish government's expense, which, you know, is the minimum they could do. Around this same time, the vaccine technique was spreading around the world. Pretty much as long as you had a live cow with cowpox or somebody with a fresh cowpox pustule, you could generally vaccinate. As the years went on, smallpox became rarer and rarer, less and less deadly, and the vaccine became more effective. A solution to the earlier problem of transporting the vaccine came about in the 1900s in the form of freeze drying, which involved rapidly freezing the material and then putting it under a vacuum so the ice sublimates. The water vapour evaporates off the ice without turning into water itself. And then it's dried again to get rid of the remaining moisture, and there you have it, a dry vaccine that hasn't been compromised in any way. If it's properly stored, this material will last a long time and can be easily made live again by just adding water. The technique was developed in Paris in 1909, and by 1918 it was able to be used to allow the smallpox vaccine to last for several months. And it was this that enabled the vaccine to reach some of the last corners of the world, the hot tropical climates that it just hadn't been able to survive in before. This vaccine could last several months in very hot temperatures. It was amazing. This was the final road bump that meant the smallpox was able to be eliminated in the final few places and therefore be eliminated worldwide. And then in 1959, the bifurcated needle was patented, which changed the vaccine game. It basically allowed less vaccine materials to be used for each dose and was just generally much easier. It sped everything up hugely. On the 9th of December 1979, after 2 years of analysis of national records, it was certified by an international commission of smallpox clinicians and medical scientists that smallpox had officially been eliminated worldwide. There was no longer a single person suffering from smallpox in all of the world, and therefore it couldn't be caught anymore. Apart from a few vials and a few select labs around the world, smallpox is gone. All because of vaccines, and to this day it's the only infectious disease in humans to have been eradicated by deliberate intervention. Routine smallpox vaccination in the UK had actually already ended in 1971 after it had been eradicated in the country, and a couple of years later it stopped being routinely given in the USA as well, and now nobody has it, like all around the world. Why do they need a vaccine for a disease that just no longer exists? We don't need it anymore. It is worth mentioning though that not all diseases are as easy to eradicate as smallpox. Smallpox just made a very good candidate for eradication because it can only affect humans. It can't jump from animals to humans. It's very easy to diagnose, and the vaccine was relatively cheap. It was also only contagious when the symptoms were obvious, unlike other diseases such as COVID-19, which as we know can be contagious before you've got any idea that you're ill. Because of these reasons, the World Health Organization had resolved to eradicate the disease in 1959, and they succeeded eventually. But as we all know, the smallpox vaccine isn't the only one, and this video is far from over. There's so many other vaccines we can talk about as well, so what came next? It's widely considered that the next successful vaccine was created in 1881 by French biologist Louis Pasteur against anthrax. I must admit this shocked me. I never would have put my money on anthrax vaccine being the second one, but at this point in time it was only for animals and wouldn't really be used in humans for another 70 years or so. Again, I have also made a video about anthrax, or more specifically the 2001 anthrax attacks, so if you want to go watch that for a bit of a deeper understanding, then please feel free. Pasteur was inspired by Edward Jenner a lot in his work, and he reasoned that if a vaccine could be found for smallpox of all things, then a vaccine could be found for all diseases. Around 1877, Pasteur was studying chicken cholera, a disease that was destroying the breeding chicken population at this time. The next year, he had found the causative virulent bacteria causing this chicken cholera, and he'd begun inoculating chickens, but far too many died in the process for his liking, so he continued in his research. It was then that he made a big discovery that would change the study of virology to this day. He found that old bacterial cultures lost their virulence. He basically instructed his assistant to inject the chickens with a fresh culture of the viral bacteria before a holiday. The assistant forgot and went away, and when he returned a whole month later, he performed their standard procedures using the old cultures. It was found then that the chickens only showed mild signs of the disease and survived. Intrigued, Pasteur injected them all with fresh bacteria and the chickens didn't become ill. This was when the idea of immunity was discovered, because remember, this wasn't the process used in smallpox. They were using cowpox to fight smallpox, but Pasteur found that using a weakened form of the disease in question provided immunity. The weakened disease had taught the chicken's immune system to fight the infection without causing any serious harm. This idea is what we today would call a live vaccine. Pasteur knew that this idea could be used for other diseases, so he continued on with his research, experimenting time and time again. Before his interest in chicken cholera, Pasteur had been studying anthrax, an infection caused by a bacteria called Bacillus anthracis. Around this time, there had been an anthrax epidemic in France and some other parts of Europe that had been killing a huge amount of sheep, and it was beginning to infect humans as well. A German physician called Robert Koch had been the one to announce the isolation of the bacteria that caused this, the Bacillus anthracis, which Pasteur then confirmed and said he wanted to apply the idea of vaccination to this bacteria. He actually managed to obtain financial support to do this, mostly from farmers, and he wanted to conduct a large-scale experiment. He produced vaccines made from weakened Bacillus anthracis, and in May 1881 he made public demonstrations on 24 sheep, 1 goat and 6 cows, injecting them with 2 courses of this new vaccine 2 weeks apart. Then, at the end of the month, all of the animals were inoculated with virulent anthrax, actual harmful anthrax, and 2 days later reassembled the crowds once again to show them that the vaccinated animals were still alive. As this was a proper scientific experiment, Pasteur also had a control group who he gave anthrax to without having given them the vaccines, and all of the sheep except 3 had died by then, and the live ones died by the end of that day. It was undeniable to everyone that the vaccine had worked. But a live vaccine working in animals does not mean it will work in humans. There were still quite a few years off that, with a lot more ethical questions to consider. He kind of hit a brick wall, so Pasteur decided he wanted to find another disease that afflicted both humans and animals, a disease that could be passed from animal to human, so he could once again use animal test subjects before having to test on humans. Although anthrax does affect both humans and animals, it's a bit of a complicated one in that there are so many different forms of anthrax. Again, watch my other video if you want a full understanding. Pasteur wanted a simpler disease to further study. In the end, he decided on rabies, a disease which still terrifies so many people as it has such a small survival rate. Actually, as of 2016, only 14 people have ever survived a rabies infection after showing symptoms. That's pretty much 100% fatal today, and it was definitely fatal in Pasteur's day, in which the only treatment for a bite from a rabid animal was cauterization with a red-hot iron, but the rabies would always develop eventually. It just had a very long incubation period. It turned out though that rabies was going to be a bit more of a challenge than Pasteur anticipated. The 2 diseases he'd already dedicated his life to studying were chicken cholera and anthrax, which were both caused by bacteria, a microorganism that could be easily identified. Rabies is a viral disease, not bacterial, but Pasteur had no way of knowing that at the time. Rabies couldn't be cultured in vitro or in the lab, but as it's a virus, it does have a very high mutation rate. He had somewhat of a stock of dogs infected with rabies already, from which he would extract infected material, finding quickly that when the infected material was injected into different species, the virulence decreased. He took what was a highly virulent rabies strain and passed it through rabbits multiple times, each time the virus decreased in effectiveness. He then air-dried sections of infected rabbit spinal cord to weaken the virus through oxygen exposure, although it would later be found that this air drying didn't make much of a difference. And from there he had the basis of a live vaccine, a very weakened version of the drug. He vaccinated 50 dogs with this weakened material and managed to successfully protect every single one of them. So once again, he had proof of vaccine working in animals, but still hadn't tested anything on humans. Whilst clearly a very talented scientist, Pasteur actually wasn't a licensed physician, so legally couldn't really test on humans. But then one day in July 1885, 2 local doctors came to him with a patient, 9-year-old Joseph Meester, who had been bitten by his neighbour's rabid dog. Joseph was doomed to die regardless, and as I said, nobody had ever survived rabies up to this point, and they had no other options. In the presence of the 2 doctors, Pasteur injected Joseph with his rabies vaccine, and he received 13 doses over a period of 11 days. Against all odds, he survived. Before this, Pasteur had vaccinated 2 other people who they believe had been exposed to rabies. One of them had remained well, but it turns out they'd never got rabies in the first place, and the other did develop rabies and did die. But after Joseph survived, word spread and several more desperate people exposed to rabies ended up travelling to Pasteur to receive the vaccine. Throughout 1886, he administered 350 people with the vaccine, and only one of them ended up developing rabies. Not a bad statistic. It would turn out that his anthrax vaccine also worked in humans as well, but they wouldn't be available for human use until 1940 after being further developed in the Soviet Union. After news of the rabies vaccine spread, Pasteur became a world-renowned hero, and he would receive donations from all over the world, enabling him to open the Pasteur Institute for the research of further vaccinations. The rabies vaccine was actually called Pasteur's treatment at this time, but he decided to honour Edward Jenner by naming his discovery a vaccine. But it's actually Pasteur's development that's closer to what we know as a vaccine today, a substance used to stimulate the production of antibodies and provide immunity against one or several diseases. A vaccine today is a suspension of live or inactivated microorganisms administered to persons or animal to introduce immunity, whereas Jenner's smallpox vaccine was a completely different disease, cowpox as we know, that just so happened to be similar enough to induce immunity. After Pasteur and the rabies vaccine, science seemed to have twigged on and the vaccines started coming in thick and fast. By the turn of the century, German physician Emil von Behring had published an article with Japanese Kitasato Shibasaburo, reporting that they had developed antitoxins against both diphtheria and tetanus, having injected the toxins into animals, and the animals developed immunity. They derived antitoxins, which we now know contained the all-important antibodies from serum that could be injected into other animals to induce immunity. This wasn't a vaccine as we know it today, this was something called serum therapy, and it's important to note that back at this time, the late 1800s, they didn't have knowledge that we have today surrounding antigens and antibodies. All that most scientists in this field knew was that some chemical found in the blood of recovered patients, whether we're talking animal or human, acted against whatever it was that caused certain diseases, in this specific case, diphtheria and tetanus. They noted that the antitoxin, as they called it, remained even after the blood cells were removed, leaving what they called the serum behind. When this serum was injected into an infected patient, it enabled their body to more effectively fight the disease. And all of this was being discovered at the aforementioned Pasteur Institute. Scientists at the Institute quickly realised that a single human just couldn't produce enough blood to conduct testing on the scale they needed. So instead they began injecting horses with increasing doses of the diphtheria toxin, which would immunise them and turn them into what was effectively blood serum factories. It turns out though that using this technique they actually had more success with tetanus than they did with diphtheria. By the time World War I came around, this process had been perfected, and broad-scale serum therapy of wounded soldiers in military hospitals was immediately introduced. Tetanus is an infection caused by bacteria that can be introduced to the body via cuts and scrapes, like stepping on a nail or being scratched by an animal, for example. And it can cause lockjaw, painful muscle spasms, a fever, and it can get pretty bad even today if left untreated, or if you're unvaccinated. Neonatal tetanus, as in babies catching tetanus before they're eligible for the vaccine, is actually still hugely fatal in many parts of the world. It is a horrible, horrible disease, and it's not something that you want. My favourite podcast ever, This Podcast Will Kill You, actually just released an episode on tetanus, so if you want to go and learn more, I highly recommend you go and listen to that. It is so interesting. I was literally listening to it at the yard this morning. As you can imagine, tetanus is a huge risk for soldiers on a battlefield, so a treatment against it was a game changer when it came to war. But whilst tetanus proved to be successful as a serum therapy, they were having a bit more trouble with diphtheria, which is a highly contagious bacterial infection that affects the nose and throat. It literally suffocates people to death, mostly children. For many decades, more than 50,000 children in Germany specifically would die from diphtheria every year, as well as similar rates across the rest of the world. At this time, it had up to a 50% mortality rate, so people were pretty desperate to put an end to it. Emil von Behring was determined to be this person, and from the 1890s, the serum technique did show promise for this. A report from 1894 showed that the results for 220 children suffering from diphtheria was a 70% cure with serum therapy, depending on when the treatment began. If your treatment started within 2 days of diagnosis, it was almost 100% successful, but the longer it took to get the treatment, the higher the mortality rate became. Overall, with serum therapy, the mortality rate dropped from 50% to 24.5%. And then with further refinement of the serum over the years, the mortality rate dropped to 1 to 5%, a huge success. But there were roadblocks to overcome, including the fact that the public still didn't quite trust it, and this was compounded when an infant died of anaphylactic shock after being administered with the serum. She was allergic to something in it. And this was only serum therapy. It could only actually prevent diphtheria for a short amount of time. It was a treatment rather than a vaccine. For it to actually be considered a vaccine, von Behring had to find a way to inactivate the diphtheria toxin without diminishing its effectiveness at causing immunity. In 1901, von Behring used a diphtheria inoculation of bacteria with reduced virulence, which helped the body produce antitoxins. From there, the development of an actual vaccine would only take a few years, and in 1913 he went public with his Diphtheria Protect agent, which contained a mixture of diphtheria toxin and therapeutic serum antitoxin, designed for long-term protection. In 1923 it would be released for public use, and the next year a similar vaccine for tetanus was released, although that one was an inactive vaccine. In the years between, vaccines for typhoid fever, the bubonic plague and tuberculosis had all been created, and I wish I could go in depth into the discovery or creation of each and every vaccine, but we'll be here all night. So we'll focus on tuberculosis, which was huge, discovered by French physician Albert Comet at the Pasteur Institute. In the 1880s, German microbiologist Robert Koch had discovered the bacteria responsible for TB, and in 1906 a vet and immunologist had established that immunity to TB was associated with living bacteria in the blood. So from there, Calmette had a pretty good idea on how this all worked. He researched how immunity would develop in animals, and then he worked to produce less and less virulent strains of bacteria, transferring from culture to culture. In terms of vaccines, with all of the prior information he had, all the people who had put in the work already, it was fairly easy to actually discover a vaccine that worked, and in 1921 they used it on newborn infants in Paris. However, in 1930 there was a bit of drama when 72 vaccinated children developed TB in Germany, so it was recalled and then reinstated a couple of years later when safer production techniques had been used. As we know, tuberculosis was one of the biggest killers throughout the 19th and 20th centuries, and before that, but now thanks to vaccinations, it's much rarer. Although according to the World Health Organization, 1.5 million people worldwide did die from TB in, I think it was 2016, but I can't remember what year it was, but a year recently. I can't talk for vaccine schedules in every country around the world, but the TB vaccine is actually now only given in the UK on the NHS when a child is thought to have an increased risk of coming into contact with it, and it only needs to be given once in a lifetime. It's not part of the sort of like routine schedule. Through to the end of the 20th century would see the vaccines for pertussis, yellow fever, typhus, influenza, tick-borne encephalitis, Japanese encephalitis, the anthrax vaccine was finally released, adenovirus, measles, mumps, rubella, pneumonia, meningitis, Hep B, chickenpox, Q fever, hantavirus, hemorrhagic fever, hepatitis A, Lyme disease and rotavirus. So many vaccines. And of course also polio, which is the next big one I want to talk about. Polio was huge, and countries all around the world faced epidemic after epidemic. In 1908, it had been introduced that the infectious agent in polio was a virus, which, as we've already discussed, immediately makes things a bit more complicated than with a bacteria. It's difficult to create a vaccine. It's actually really interesting how Karl Landsteiner and Erwin Popper made the discovery it was a virus. They filtered spinal cord fluid from a person who had died from polio, knowing that the tiny filters would trap any bacteria. But there was no bacteria to be found. So they injected the filtered substance into monkeys who did develop polio, which led them to conclude that a particle smaller than bacteria caused this disease. This was 1908, but nobody would actually be able to see the virus until the 1950s. It's just incredible to me that people can think so outside of the box. Like, how do you even begin to figure that out when the technology isn't going to catch up for another 4 decades? Polio is a dangerous, life-threatening infectious disease. However, most people who get infected with poliovirus, so about 72 out of 100 people, will not have any visible symptoms at all. 1 in 4 people will have flu-like symptoms, so sore throat, fever, tiredness, etc. that will go away after 2 to 5 days. A much smaller proportion of people, so less than 1 out of 100, will develop more serious symptoms that affect the brain and spinal cord, including paresthesia, so pins and needles, meningitis, or paralysis or weakness of the arms and legs. It can lead to permanent disability and even death. Between 2 and 10 out of every 100 people who have paralysis from polio will die because the virus affects the muscles that help them breathe. There's also post-polio syndrome, in which children who seem to fully recover will develop new muscle pain, weakness or paralysis as adults, anywhere from 15 to 40 years later. Countries were faced with endemics of polio every year. Children were disproportionately affected. Nowadays, we all know that polio is spread through the faeces of an infected person, or by the droplets launched into the air when an infected person coughs or sneezes. If the virus gets into your mouth, it travels to your throat and bowels where it starts to multiply. But in some cases, it can get into the bloodstream, and that's how it spreads to the nervous system and causes the much more serious symptoms. Back in the early 1900s, scientists believed that polio was simply a disease of the nervous system, but in 1941 a man called Simon Flexner proposed that it entered the body through the nasal passage. However, it was found that poliovirus was rarely found in nasal tissue. More than that, they knew that it was not only found in the nervous system, but in the digestive system too. From this, scientists deduced that poliovirus entered the body through the digestive system and got into the bloodstream from there. This meant that maybe they could find a vaccine that would produce antibodies to fight the virus before it reached the nervous system. 7 years later, a man called Hilary Kaprowski tested his attenuated, weakened virus on chimpanzees with great success, so him and his assistants became the first human test subjects. They both took the vaccine and suffered no side effects. However, 2 years later it was found there are actually 3 types of polio, so any vaccine released to the public would have to be effective against all 3. Luckily, that soon came along. In April 1954, massive polio vaccine trials began in the US, with the Vaccine Advisory Committee approving Jonas Salk's vaccine. The very next day, the trial began with the vaccination of thousands of school children, and all in all, over the course of the trial, 1.3 million children would participate. It was randomised, meaning that children were randomly assigned to either the vaccine group or the control group, and nobody knew which child had which. There was also a smaller control group that received no injection at all. It would take a year to analyse the results and determine whether this vaccine should go out to the general public, with results announced in April 1955. It was found to be 80 to 90% effective against paralytic polio, and it was licensed by the USA government later that very same day. Thanks to widespread vaccination, the US has now been free of polio since 1979 and the UK since the mid-80s. And according to the World Health Organization, there are now only 2 countries in the world that never stopped polio transmission: Pakistan and Afghanistan. Polio was eliminated completely in Europe in 2002. In the UK today, polio is part of the routine childhood vaccinations, and from my research it looks like we actually receive 5 doses throughout our childhoods, at 8 weeks, 12 weeks, 16 weeks, 3 years and 4 months, and 14 years old. The USA is very similar at 2 months, 4 months, 6 to 18 months, and 4 to 6 years old. It's likely very similar in your country as well. I just mentioned those 2 because that's where 90% of my audience comes from. In the UK, babies under 1 year old are now routinely vaccinated with diphtheria, hepatitis B, Hib, polio, tetanus, whooping cough, rotavirus, Men-B and pneumococcal infections. Children aged 1 to 5 receive further doses of all of those, as well as measles, mumps and rubella, a yearly flu vaccine, HPV, and students headed off to uni are given the Men-ACWY vaccine to prevent meningitis and septicemia. When you reach 65 and over, you're offered the pneumococcal vaccine again, as well as the flu and shingles. All in all, it's a pretty effective programme. At least I've never caught any of the aforementioned diseases, which suggests that maybe it works. This is from the NHS website now though, in 2022, so I don't know what my vaccine routine would have been 28 years ago. I'd actually be very intrigued to know. Depending on where you travel in the world, you might be expected to receive vaccines for other diseases that arrive elsewhere. I was actually really interested to learn fairly recently that in the USA, Canada, Australia as well, I think, probably other countries around the world, a vaccine is routinely given against chickenpox, which is not part of the routine schedule here in the UK, where it's classed on the NHS website as a common childhood infection. It's just kind of a given here in the UK that at some point you're gonna get chickenpox as a child, you'll be itchy for a bit, and then that's it. It literally never occurred to me that a vaccine could be available for it. I think literally everyone I know has had chickenpox. However, the vaccine is currently available on the NHS for people who are in close contact with somebody who could be particularly vulnerable to chickenpox or to its complications. I don't know how relevant that is to the video, it's just a little tidbit I learned recently. I wonder why we don't get it here. All of which I suppose brings us to today, with new vaccines still being released on a regular basis. In recent years, we've seen the first vaccines for hepatitis E, enterovirus 71, which is one of the causes of hand, foot and mouth disease, malaria, dengue fever, Ebola, and most recent one of course being COVID-19. And because I clearly love drama, and hopefully we're far enough into this video now that anyone uninterested in this topic will have got bored, let's talk about how the COVID-19 vaccine was developed and how it was developed so quickly. So, as I'm sure a lot of us know by now, the virus that causes COVID is the SARS-CoV-2 virus, first identified in December 2019. A year later, on the 8th of December 2020, the UK became the first country in the world to deploy an approved COVID-19 vaccine on 90-year-old Margaret Keenan in Coventry. She received the Pfizer vaccine. Just 3 days later, Pfizer was the first to receive emergency use authorization in the USA. Now, one of the biggest arguments you'll tend to hear against the COVID vaccine is that it was developed so quickly, that these things usually take years and years to go through testing and get clinically approved. And that's not wrong. But A, this was an unprecedented world event, meaning that all of the bureaucracy that tends to hold these things up suddenly moved very fast. And B, the basis of this vaccine is something that's been in development for years. Coronaviruses aren't a new thing by any means. Scientists have been working for many years to develop vaccines against other known coronaviruses, such as SARS and MERS. SARS-CoV or CoV-2 that causes COVID is related to these very closely, meaning that all of the knowledge gained through the past research into the other diseases came in very handy when speeding up the vaccine development here. However, up until this point, only vaccines for animal diseases caused by coronaviruses had been produced, and vaccines against MERS and SARS had only been tested on animals. In what is probably an offensive dumbing down of the scientists' jobs here, all they've really had to do was take the basis of what they'd already researched and figure out a way to ensure its safety for human use. As Dr. Eric Jaeger, a professor of microbiology at Albany College of Pharmacy and Health Scientists, told Medical News Today, early efforts by scientists at Oxford University to create an adenovirus-based vaccine against MERS provided the necessary experimental experience and groundwork to develop an adenovirus vaccine for COVID-19. As we must all know well by this point in the video, traditionally vaccines have contained weakened or inactive parts of a particular virus to trigger an immune response from the body. However, historically, it's taken years to weaken the disease enough or narrow down what in particular causes the disease. But thanks to modern technology, researchers had been successfully able to uncover the viral sequence of SARS-CoV-2 by January 2020, just 10 days after the first reported case in Wuhan, China. This is technology that humanity has never had before. And remember, this is something the whole world was working on. The whole world was cooperating in a way it never had beforehand. There was no competition, it was just, let's find it together. In more recent years, thanks again to new DNA technology, researchers have been able to develop vaccines that rely on extracting RNA or DNA from pathogens and using these as the vaccine instead of an inactivated form of virus. Although the risk with an inactivated form of virus is very slim, it is still a risk. There's like the tiniest risk that you could contract the disease. With the RNA or DNA, you're just taking bits of the genetic material that just can't cause disease and injecting it into somebody, meaning that you cannot possibly contract the disease, but your immune system can still learn to fight it. You've probably heard scaremongering around the word mRNA, but it's basically like the software that runs the cell, with Moderna's president, Dr. Stephen Hodge, telling Time magazine in January 2020, mRNA is really like a software molecule in biology. So our vaccine is like the software program to the body, which then goes and makes the viral proteins that can generate an immune response. This idea goes as far back as January 1988, when Robert Malone wrote that it might be possible to treat RNA as a drug. This has been studied for decades. You might have seen some people on the internet saying that mRNA can affect our DNA, it can literally change our DNA, but that is just simply not true. mRNA never enters the nucleus of a cell where our DNA is located, and it simply can't alter it. And it doesn't last long in the body, with our cells doing their jobs and breaking it down in just a few days. From what I can gather, it was clear from the early days of 2020 that an mRNA vaccine was likely going to be the way forward here, but there were actually 194 vaccines that were originally submitted to preclinical trials. RNA vaccines, inactivated viruses, protein vaccines, DNA vaccines, viral vectors, etc. Only 42 of these went forward to phase 1 testing, undergoing safety tests in healthy young adults. Again, this process was all accelerated thanks to worldwide cooperation and worldwide funding. It cost millions and millions of dollars for the early development of a vaccine usually. And whilst I haven't been able to find any figures when it comes to the COVID vaccines, I can imagine potentially billions of dollars being put into this. Definitely billions of dollars. Usually it takes a long time to get that kind of funding, but people were desperate in this case. What slows down medical trials isn't always the drugs, it's usually just the bureaucracy, the funding, things like that. Phase 2 trials had 44 vaccines being tested in broader groups of people. I'm honestly not sure how it jumped from 42 in phase 1 to 44 in phase 2, but it did. We'll just go with it. Phase 3 was down to 40 vaccines being tested in large international trials. Now, clinical trials can combine these phases. It's common practice that is also completely safe and ethical and gets things moving along quicker. It became clear soon into the trials that the vaccines were not only safe, but they were also working. Moderna were the first ones off the mark when they were able to create a prototype vaccine within just days of the virus's genome sequence becoming available online. Within 10 weeks, they had collaborated with the US National Institute of Allergy and Infectious Diseases to conduct mouse studies and launch human trials. In March 2020, BioNTech partnered with Pfizer, who would later be the first vaccine to be approved. Both Pfizer and Moderna use mRNA. BioNTech Pfizer submitted an emergency use authorization request to the FDA in the USA for their mRNA vaccine on the 20th of November 2020. On the 2nd of December 2020, the UK's Medicines and Healthcare Products Regulatory Agency gave temporary regulatory approval of also the Pfizer-BioNTech vaccine. By the 21st of December, many countries around the world and the EU had approved the use of Pfizer. Soon, Moderna followed suit. I am part of Moderna gang. Currently, worldwide, there are 23 vaccines being offered to the general population. Behind Moderna and Pfizer, the next most popular ones are likely the Johnson & Johnson and AstraZeneca, which are both vector vaccines, so not mRNA. So if people don't feel comfortable with the mRNA option, there is still the other type, vector. In this type of vaccine, the genetic material from the COVID-19 virus is placed in a modified version of a different virus. When this viral vector gets into your cells, it delivers genetic material from the COVID-19 virus, giving your cells instructions on how to fight it. Viral vector vaccines also cannot cause you to become infected with the COVID-19 virus or the viral vector virus. Obviously, there has been some very vocal opposition to the COVID-19 vaccines, and there are a sector of people out there who just don't trust it and actively oppose it. It's a very difficult topic to cover, anti-vaxxers, and one that I simply don't have time to really delve into in today's video. But vaccination, to an extent, is a personal choice. If you're affecting you, and only you. However, there becomes a point where it's our responsibility as a society to protect those who can't receive the vaccine for themselves for medical reasons. If large swathes of society felt the same about the smallpox vaccine or the polio vaccine, they would likely still be diseases that we'd have to worry about today, and believe me, none of us want that. None of us want smallpox. Anti-vaxxers aren't new with COVID, of course. There have been anti-vaxxers all throughout history. People don't trust things being put into their body, and I do understand that. I really do. The big issue comes when people have platforms like they're able to have with social media today. People can spread misinformation so quickly and so effectively. You see people brainwashed completely by social media, by anti-vaxxers, by conspiracy theorists. I can't help but make connections back to the satanic panic of the late 20th century. For certain people, it becomes somewhat of a cult. It's a moral panic. It just becomes your way of life, and you get taken over by it. If you have genuine scientific knowledge and facts to back up the points you're going to make in terms of being anti-vax, then sure, let's have a two-sided conversation. But all too often, that's not the case, is it? You're met with conspiracies and craziness. If somebody is a COVID denier and anti-vaxxer, more often than not, there's nothing you can really do to have a realistic conversation. And let's not even get started on vaccines and autism. No, vaccines do not cause autism. It's been proven by studies time and time again. The guy that sort of put this out there in the world isn't even a doctor anymore. He got struck off. Plus, I don't know about you, but I'd much rather have an alive autistic kid than a dead non-autistic one. Again, I understand people being hesitant about vaccines. I understand people wanting to educate themselves further, find out what's going into their bodies before they do it. I understand being scared or worried. I don't understand the conspiracy theories and the panic and just the whole culture that's come around anti-vaxxers nowadays. It is pretty exhausting. The level of misinformation that's spread around these things is so dangerous, so much more dangerous than the vaccine itself. I truly believe that. And there are people out there who do react badly to vaccines in general. I understand there are people out there who have certain allergies, their bodies just can't take it. And it's for that reason, it's for those people who can't have the vaccine or who are vulnerable, that everyone else needs to do their part and have it. I don't know if that's a controversial opinion, I don't feel like it is, but we are on the internet, so it probably will be. Is anybody else vaccinated out at this point? Because I think I am. I've been filming for about 4 hours at this point. This video was so much longer than I originally intended, but I just kept researching new interesting things and I just couldn't stop. If you have any more information or fun facts about the history of vaccines that I haven't covered in this video, because believe me, I know there's so much more I could have said, please stick them in the comments down below. I have thoroughly enjoyed researching this one and I hope you've all enjoyed hearing about it. A huge thank you to Native for sponsoring this video. Please go and try out their shampoo and conditioner if you're interested. The link will be in the description box down below. Thanks for watching and I'll see you in the next one. Bye guys.